Hello everyone, welcome to Brain Blitz Audios. Today is a very special episode of Cbse board exam because we're going to be discussing the sample paper for the year 2021 released by Cbse. This sample paper for mathematics is a very important aspect for students preparing for the year 2021. So in this episode, we'll be trying to explain some questions of the sample paper, and we'll be trying to cover as much as possible. And further questions will be taken up in the next video. So let's start with the sample paper published by Cbse for the year 2021. This is our first question. Check whether the function f from R to R defined as fx is equal to x cubed is 1, 1 or not. So we need to find out that the function, which is defined between real numbers, is a 1, 1 function or not. That means every element in the domain of this function will be connected to at least one element of the range of this function. That is what is called a 1, 1 function. So how do you prove this relation? So in this function, fx is equal to x cubed. So in order to prove whether a function is 1, 1 or not, what we do is we let f of x1 equals f of x2. And when f of x1 is f of x2 and x1 is equal to x2, then we can say that the function is 1, 1. So for x1, the function f will be x1 cubed, and for x2, the function again will be x2 cubed. So x1 cubed is equal to x2 cubed. We just take the cube root in order to get the relation. x1 is equal to x2. So when x1 is equal to x2, the function f is a 1, 1 function. So this is a typical 1-mark question in board exams. The thing is that the question is the question is short, but it may not be easy. Sometimes you need to have in-depth knowledge about the subject as well and the lesson you're studying. So in this year's sample paper, we have an OR question for question number 1. It says, how many reflexive relations are possible in a set A where NA is equal to 3? For reflexive relations from A to A, so reflexive means that if A comma B belongs to R, then B comma A must belong to R. So we need to find out how many reflexive relations are possible when there is a relation from A to A. So the formula here is 2 raised to n squared minus n. And we know the value of n as 3. So since n is equal to 3, then the reflexive relations will be 2 raised to 3 squared minus 3. That is 2 raised to 9 minus 3, which is equal to 2 raised to 6. So according to the sample paper key, 2 raised to 6 is the answer. If you can expand it, it's well and good. The answer will be 64. So that is just 8 squared. So 8 squared is 64. So 2 raised to 6 is equal to 64. So if you write 2 raised to 6 or 64, you'll get the answer. And you'll get your marks. This is the second question in the sample paper. A relation R in a set S which has elements 1, 2, 3 is defined as R equals 1, 1, 1, 2, 2, 2, and 3, 3 inside that relation. Which element or elements of relation R must be removed to make R an equivalence relation? An equivalence relation is a relation which is symmetric, reflexive, and transitive. Now, when a function is purely symmetric, and there is no way we can prove that it's reflexive or transitive, then we can also say that it's an equivalence function as well. So in this particular function, that is S is the set 1, 2, 3, and R is the relation 1, 1, 1, 2, 2, 2, and then 3, 3. We need to prove whether the relation is reflexive. So for the condition for a function being reflexive is that a comma b belongs to R, implies that b comma a must belong to R. Now if we take the case of 1, 2, so you can see that 1, 2 belongs to R, but the element 2, 1 does not belong to R. So therefore, because of this term 1, 2, we cannot prove that this relation is reflexive. So therefore, we must remove 1, 2 in order to make this an equivalence relation. So if you write 1, 2 as the element to be removed, then your answer will be correct. And this is how you can prove it. Now to question number 3. A relation R in the set of real numbers is defined as R equals a comma b such that root a is equal to b. We need to prove that this is a function or not, and we need to justify our answer. So we have the relation R equals a comma b such that root a is equal to b. The problem here is that root a exists only for positive values. Otherwise, it is imaginary. So what essentially occurs is that the domain of f is minus infinity to infinity, but the range of this function is 0 to infinity. So root a can only exist from 0 to infinity, while b can exist from minus infinity to infinity. So here the range of the function is not equal to the codomain. And when the range is not equal to the codomain, then the relation R is not a function. So that is how you can justify the fact that this relation is not a function. Now this was the first part of the third question. We also have an OR question associated with question 3. Now this question states that an equivalence relation R in the set A divides it into equivalence clauses A1, A2, and A3. You need to find the value of A1 union A2 union A3 and A1 intersection A2 intersection A3. So what is an equivalence clause? An equivalence clause is such that X belongs to the set such that X has a relation with the element A. So over here we have the equivalence clauses as A1, A2, and A3. So therefore, the equivalence relation that we get will be R equals A1, comma A1, A2, comma A2, A3, comma A3. That is how you can represent the relation when you have the equivalence clauses. So how do we prove how do we find out the value of the union and intersection? So if we take A1 union A2 union A3, union of the terms, then we have to add everything up. So all the terms come together. So it'll be a1 comma a2 comma a3 inside the set, and that set is the set A. So therefore the value of a1 union a2 union a3 is equal to A. Now what about a1 intersection a2 intersection a3? Over here in the intersection function, we are to take out the common points that are present all over the function. I mean, all over the operation. So in this operation, a1, a2, and a3 are distinct equivalence classes, so therefore there is nothing common in between them. So you will have a null set, which will be the value for a1 intersection a2 intersection a3. So there is nothing common. So A and phi are the answers to the operators in the question. The trick here is to use the equivalence clause to form the equivalence relation and then to use the union and intersection appropriately. Next, the question is, if A and B are matrices of order 3 times n and m times 5 respectively, then find the order of the matrix 5a minus 3b given that this matrix is defined. So, in this question, the order of the matrix A is 3 times n, and the order of matrix B is m times 5. Now, the question says that 5a minus 3b is a matrix that exists, so it is present. Now, how can you add or subtract two matrices? It is very simple. For addition or subtraction, the order of both the matrices must be the same. So over here, both the matrices must have the same order. So the order of A is equal to the order of B. So that means 3 times n is equal to m times 5. And using this, we can find out that n must be equal to 5 and m must be equal to 3 in order for this relation to exist. In order for this equality to exist, n must be equal to 5 and m must be equal to 3. And therefore, since the sum or difference of the matrices has to have the same order, the order of 5a minus 3b is equal to 3 times 5. So this is the final answer that they want, the order of the matrix. Now let's look at the fifth question of the sample paper. We need to find the value of a square, where A is a 2 by 2 matrix. The elements are given by aij equals 1 if I not equal to j, and 0 if I is equal to j. So first clue is that A is a 2 by 2 matrix. In a 2 by 2 matrix, you have A11, A12, A21, and A22 as the elements, the general elements present. First row, first column, first row, second column, second row, first column, and second row, second column. So this is a 2 by 2 matrix. Now, in order to fill out the matrix A, the other clue that we should use is that aij equals 1 if I not equal to j, and 0 if I equals j. So I and j are the number of rows and the number of columns respectively. So therefore, the first is A11, and since I equals j here, you get the value 0. For A12, I not equal to j, so the value is 1. For A2, 1, it is again the same. They're not equal, so you get 1. A2, 2, both I and j are equal, so you get a 0. So the matrix A is 0, 1 for the first row and 1, 0 for the second row. Now, we need to find the value of A squared. A squared is basically A times A. That is equal to 0, 1, 1, 0 times 0, 1, 1, 0. The important point to note here is that this is not simple multiplication. First, we multiply the first row to the first column, then the first row to the second column, then the second row to the first column, and then the second row to the second column. And that is how you multiply in matrices. So when we're taking that order, the first term will be 0 times 0 plus 1 times 1. Then it will be 0 times 1 plus 1 times 0. Over here, it will be 1 times 0 plus 0 times 1. Then it will be 1 times 1 plus 0 times 0. So this is how you multiply matrices. The final value of A square is equal to 1 times 1 is 1. Over here, completely 0. Here as well, it is completely 0. 1 times 1 is 1. So A square is equal to 1, 0, 0, 1. And this is also similar to the identity matrix. So therefore, the value of A square is the same as the value of the identity matrix, 1, 0, 0, 1, for a 2 by 2 matrix. Now, question number 5 has an OR question alongside it. So let's look at the OR question. Given that A is a square matrix of order 3 by 3 and the determinant of A is minus 4, we have to find the adjoint of A. So the order, let's write the things down. Order is 3 times 3. Determinant is minus 4. How do you find the adjoint of A? Here is the formula that must be used. The adjoint of A is equal to the determinant of A raised to n minus 1. This is the golden formula here. When we apply the formula and you put in the values, so the adjoint of A will become minus 4 times, since the order is 3, 3 minus 1. So it'll be minus 4 the whole squared. Minus 4 the whole squared is equal to 16. So the adjoint of A is equal to, no, it's not the adjoint of the determinant. It's adjoint of A is equal to 16. And that is the simple way in order to find out the adjoint when you have the order and the determinant given to you. Let's look at question number 6. If A is a matrix Aij, it is a square matrix of order 3, 3, and the determinant of A is minus 7. We need to find the value of this, equation, where capital Aij is the cofactor of the element small aij. So at first glance, this question looks as if you need to write down the entire determinants, and you need to find out the matrix and the cofactor matrix as well. But trust me, you don't have to go all that way. The trick here is to use this property. If elements of a row or column are multiplied with cofactors of any other row or column, then the sum of these terms is equal to 0. Now, you just need to check it out here. A11 is the element of one row, and capital A21 is the cofactor of the second row and the first term. Similarly, A12 times capital A22, A13 times capital A23. So as you can see, all the cofactors are from the second row and all the elements are from the first row. So this satisfies the property given here. So according to this property, the whole value of A11 capital A21 plus A12 capital A22 plus A13 capital A23 is equal to a very big 0. So the answer to this question is 0. This is why the Section A questions are extremely tricky, and you need to watch out for all kinds of properties. Let's look at another question. This one is related to integrals. Find the integral of e raised to x times 1 minus cot x plus cosec square x dx. So, in this question, let's consider f of x as 1 minus cot x. The reason why I do that, because I spotted an e raised to x multiplied to these terms. Now, what will be the derivative of this function? So that will be d by dx of 1 minus cot x, which d by dx of 1, a constant, is 0, minus d by dx of cot x is minus cosecant square x. Let me write it down. D by dx of cot x is minus cosecant square x. So therefore, minus of minus cosecant square x is just plain old cosecant square x. So this is the value of f dash x. So we have fx as 1 minus cot x and f dash x as cosecant square x. So therefore, it is similar to the property integral e raised to x into f of x plus f dash of x dx. So, what will be the right-hand side of this integral? The solution to this integral will be e raised to x times f of x plus c. So, in accordance with that property, integral e raised to x 1 minus cot x plus cosecant square x will now be equal to e raised to x times 1 minus cot x plus c. And this is the answer to the 7th question. Again, we have an OR question for question number 7, which is to evaluate the definite integral from minus pi by 2 to pi by 2 x squared sine x dx. Again, with respect to this integration, if you look at the limits closely, we have an equation similar to this integral of minus a to a f of x dx. This is the question here is similar to this situation. So when you have an equation of this form, then we just check out the value of f of x. So over here, f of x is equal to x squared times sine x. What happens if you replace x by minus x? So you get minus x the whole square times sine of minus x. Sine of minus x is minus sine x, and minus x the whole square is just x squared, so it'll be minus x squared times sine x, which will be f of minus x. That will be equal to minus f of x. So over here you can find that f of minus x is equal to minus f of x. When this happens, we use another property related to definite integrals. Integral minus a to a f of minus a to a f of x dx is equal to 0 if f of minus x is equal to f of x. So if we are to use this property, then what happens is that minus pi by 2 to pi by 2 x squared sine x dx is equal to another big fat 0. So 0 is the answer to this integral because of the property that we just used. Next question. Find the area bounded by y equals x squared, the x-axis, and the lines x equals -1 and x equals 1. This is a question related to linear programming, and in case of questions with linear programming, we must always draw a graph. So in the coordinate axes, here's y, here's x, and the first thing we can write down is x equals 1 and x equals -1. So these will be lines which are parallel to the y-axis. X equals 1, and that will be x equals -1. Next, another boundary is the x-axis, so this will be a boundary by itself. And the final boundary is y equals x squared. This is a function which is parabolic. So over here and over here. So this point is -1, 1, and this point here is 1, 1, because the square of -1 is 1 and the square of 1 is also 1. So we have our points given and we have the origin 0, 0. What we have to find out is the area given here, the area which is under the curve between the three lines. The area under the curve and between the three lines is the area that we need to find out. So that is the required area. If you look at this curve, you see that this curve is symmetric. So what happens when the curve is symmetric? When the curve gets symmetric, what you can do is you just need to find 1/2 of the area and then multiply it by 2 in order to get the other half. So the required area is, instead of it requiring the area from -1 to 1, you can just make it as 2 times integral 0 to 1 y dx. So that will be 2 times integral 0 to 1 x squared dx, which will be equal to 2 times the integral of x squared is x cubed by 3. I'll take 1 by 3 outside, and the limit is from 0 to 1 again. Now what happens is that I'll multiply these two, so you get 2 by 3 times 1 cube minus 0 cube. 1 cube is still 1, so the required area is 2 by 3 square units. In these kinds of questions, it's very important to write the unit at the end, otherwise you'll lose your marks. And the final answer is the answer that they want, since it's a 1-mark question, 2 by 3 square units. Now let's look at question number 9. How many arbitrary constants are there in the particular solution of the differential equation dy by dx is equal to -4xy squared, where y of 0 is equal to 1? So the answer here lies especially in the question. The question says that this differential equation has a particular solution. And the thing about this sentence is that in a particular solution, there are no arbitrary constants. So the number of arbitrary constants for this function, which has a particular solution, is equal to another big round 0. So the number of arbitrary constants here is 0. Let's look at another OR question. The OR question for question number 9 is, for what value of n is the following a homogeneous differential equation? So if we take dy by dx as x cubed minus y raised to n divided by x raised to y plus xy square, then according to the formula, it becomes homogeneous when n is equal to 3. So that is our answer. Let's look at question number 10. Find a unit vector in the direction opposite to minus 3 by 4 j cap. So, how do you solve this question? It is best done by drawing a vector graph. So let's take a vector diagram. This is the x-axis, this is the y-axis, and this is the z-axis. It's actually perpendicular, but we draw it like this. In this question, the vector given is minus 3 by 4 j cap, which is present in the downward direction as the magnitude is negative. So this is basically 3 by 4 times minus j cap, or minus 3 by 4 j cap. It's one and the same. So minus 3 by 4 j cap occurs in the minus y-axis. We need to find the unit vector that is opposite in direction. So the unit vector found opposite to minus y-axis is actually j cap, because the opposite direction to minus y is plus y, and in the plus y axis the unit vector will always be j cap. So the unit vector in the direction opposite to minus 3 by 4 j cap is j cap. So the correct answer is j cap. Let's look at question number 11. You need to find the area of the triangle whose two sides are represented by the vectors 2i cap and minus 3j cap. So let's take one of the vectors as vector AB, and it's given, the vector's value is given as 2i cap. So the other unit vectors are zeros. So 0j cap plus 0k cap. For, let's say, AC, the vector is 0i minus 3j plus 0k. So what have I done? So what I've done is that I've taken these two vectors, AB and AC, as two sides of a triangle. So when you have two sides of a triangle given to you, then the area of the triangle ABC here is equal to half times the cross product of the two vector sides. So in order to do this question, let's find out the cross product of AB and AC. So the cross product is the determinant of the matrix I cap, J cap, K cap in the first row, 2, 0, 0 in the second row, 0, minus 3, 0 in the third row. So over here, I cap comes first, and then the determinant, so then let's find out the value of the determinant. It will be 0 times 0 plus minus 3 times 0 plus, it's instead of plus it should be minus, so minus j cap times 2 comma 0 minus 0 comma 0, then it will be plus k cap times 2 times minus 3 minus 0 comma 0. So the values for I cap will all boil down to 0. For j cap, it's going to be the same. So if I write it out plus here or minus here, it doesn't make any difference. But for k cap, one of the terms, that is 2 times minus 3, will become minus 6, and the other will become 0. So minus 6 plus 0. So therefore, the vector, the cross product of the vectors AB and AC is equal to minus 6k cap. So if you want to find the magnitude of that vector, then the magnitude of that vector is equal to just plain old minus 6. Then the area of triangle ABC is equal to half times the modulus of the cross product AB cross vector AB cross vector AC. So that is half times of say half times of 6. There is no minus because it's a modulus value. So half times of 6 is equal to 3 square units because we're finding out area. So once again, don't forget to write down square units at the end, otherwise you'll lose your marks. Question number 12. Find the angle between the unit vectors a cap and b cap, given that a cap plus b cap is equal to 1. So the given equation is that a cap plus b cap is equal to 1. The modulus of those is equal to 1. First, what we do is we square both sides. So when we square the both of the sides, you'll get a cap the whole square plus b cap the whole square plus 2 times a cap times b cap is equal to 1. So there will be a cap dot b cap. 2 times a cap dot b cap is equal to 1. So there will be no moduluses here. When you're just taking the modulus value, it becomes modulus of a the whole square plus modulus of b the whole square plus 2 times, then the dot product will be modulus of a times modulus of b times cos theta is equal to 1. So how do we solve this question? Now notice that that a cap and b cap are unit vectors. So the modulus of a cap and then modulus of b cap is just 1. And 1 square is also always 1. So 1 plus 2 times 1 into cos theta is equal to 1. So 2 plus 2 cos theta is equal to 1. Let's take 2 to the other side. So therefore 2 cos theta is equal to 2 cos theta is equal to 1 minus 2, that is minus 1. So cos theta is equal to minus 1 divided by 2. So when cos theta is minus 1 divided by 2, it is equal to cos of 120 degrees, that is cos of 2 pi by 3. So therefore, the value of theta, the angle subtended by the unit vectors a cap and b cap, is 2 pi divided by 3. And we used the angle between the unit vectors in order to find that out. But first, we just squared the equations on both sides to square the equation on both sides. Then we found out the values by putting in dot product as well in order to get cos theta. So using all of that steps, we got the value of theta as 2 pi by 3. Next question. Find the direction cosines of the normal to the YZ plane. The tricky part is to understand the normal to YZ plane. Now, if you're a brilliant student, then you will know that it's just the x-axis. Otherwise, if you're getting stuck, what you can do is just draw y and say z, like this. So you draw y and z, so this is a plane, and the axis which comes out of the plane will always be the x-axis. So the normal to yz plane will be the x-axis. So we need to find the direction cosines of the x-axis. So essentially the direction cosines refer to the cosines of the angle that a vector makes with the direction axes. So for the x-axis is 0 degrees away from the x-axis. That makes sense, doesn't it? And since it's perpendicular to both the y-axis and the z-axis, the distance, the angle here will be 90 degrees. So beta and gamma are equal to 90 degrees. And therefore, L, which is equal to cos alpha, which is equal to cos 0, is equal to 1. M, which is equal to n, because both n and m and n have the same angle, so that'll be equal to cos 90 degrees, will be equal to 0. So the direction cosines of the x-axis is equal to 1, 0, 0. So this is the value of the direction cosines. Question number 14. Find the coordinates of the point where the line x plus 3 by 3, y minus 1 by minus 1, and z minus 5 by minus 5 cuts the xy plane. So, in this question, the first thing we need to look at is the plane. Here we're given xy plane. So, in an xy plane, there is no z coordinate. So, the z coordinate value will always be equal to 0 in an xy plane. So the coordinates that we'll be dealing with are x, y, 0. Now here the equation, we have the coordinates of a point in the Cartesian form. X plus 3 by 3 equals y minus 1 by minus 1 equals z minus 5 by minus 5. Let's consider that as equal to some constant lambda. So each of these is equal to lambda. So what we get is x equals 3 lambda minus 3, because 3 goes to lambda, and then minus 3. Y will be equal to minus lambda plus 1. Minus 1 goes here. Minus 1 becomes plus 1 as it gets to the right side. And the value of z will be equal to minus 5 lambda plus 5. That is in accordance with the equation. Now, using our first hypothesis, in the xy plane, z is always equal to 0. And since z is equal to minus 5 lambda plus 5, so that means minus 5 lambda plus 5 is equal to 0. That means minus 5 lambda is equal to minus 5. Lambda is equal to 1. The value of lambda is equal to 1. Now we put lambda equals 1 in the equations for x and y. So x equals 3 times 1 minus 3, that is 3 minus 3 equals 0. And y equals minus of 1 plus 1, but that is minus 1 plus 1, which is equal to 0. So the coordinates of the point which is given are 0, 0, 0. That means this point is the origin. Again, just mentioning 0, 0, 0 will fetch you full points. Now we have the 15th question. The probabilities of A and B solving a problem independently are 1 by 3 and 1 by 4, respectively. If both of them try to solve the problem independently, we need to find the probability that the problem is solved. So A solves a problem with probability 1 by 3, so P of A equals 1 by 3. Similarly, P of B will be equal to 1 by 4. Now, we need to find out the probability that the problem is solved. So that means when a problem gets solved, then both the efforts of A and B are kept added together. So that means P of problem is solved can be written down as P of A union B. Both the efforts contribute in solving the problem. P of A union B can be written down using the formula P of A plus P of B minus P of A intersection B. So we need to find P of A intersection B. That shouldn't be a problem because in the question it says both of them try to solve the problem independently. So therefore P of A intersection B is equal to P of A P of A into P of B. So P of problem is solved will be equal to P of A plus P of B minus P of A times P of B. Now that is equal to 1 by 3 plus 1 by 4 minus 1 by 12, because 1 by 3 times 1 by 4 equals 1 by 12. We can just take the LCM as 12, and you can see it becomes 4 plus 3 minus 1. So P of problem is solved is equal to 3 minus 1 is 2, 4 plus 2 is 6, 6 by 12, which is equal to 1 by 2. So P of problem is solved is equal to 1 by 2. So that fetches you full points. If you write 6 by 12, it still fetches you full points, but then by that time it will be easy for you to simplify to 1 by 2. Now this is the last question of section A. The probability that it will rain on any particular day is 50%. We need to find the probability that it rains only on the first 4 days of the week. So the condition given is that P for rain on a day, the probability of any particular day raining, is equal to 50%. That means 1 by 2. 50 by 100, 5 by 10, 1 by 2. And what that also means that P of no rain, that means the probability that there is no rain on that particular day is 1 minus 1 by 2, 1 minus P of rain. That will be 1 by 2 as well. Now we need to find the probability that it rains only on the first 4 days of the week. So P of rains on the first 4 days. What does this condition mean? The condition means is that the first 4 days of the week will be rainy and the next 3 days have no rain. So when we're writing the probability down, we must also look at that as well. That means P of rain on the first day into P of rain on the second day into P of rain on the third day into P of rain on the fourth day into P of no rain on the fifth day into P of no rain on the sixth day into P of no rain on the seventh day. So the reason why we multiplied is that we need to get the total probability. That's why we multiplied it. If we want to find alternate probabilities like this or that, then we add up the probabilities. So over here, the first 4 days are raining, the next 3 days are not raining. So first 4 days are raining, the probability for rain is 1 by 2, 1 by 2 raised to 4 because it's multiplied 4 times. And P of no rain, that is multiplied 3 times, so again 1 by 2 raised to 3. So essentially this becomes 1 by 2 the whole raised to 7. So 1 by 2 raised to 7 is equal to 1 by 128. So the probability of raining in the first 4 days is 1 divided by 128. So that's enough for today, because we've discussed all of the questions on Section A, and more questions will follow with subsequent episodes of CBSE board exam. So don't forget to catch those up by subscribing to our channel, Brain Blitz Audios, and hitting our notifications button in front of the description box down below. So until the next CBSE board exam discussion, take care, stay safe, bye-bye for now.